Welcome to solverfy.
So let's say this is Earth. We'll assume it to be a spherical object. There is field of 150 newtons at the Newton per coulomb at the surface, which is inwards. So to find the excess charge, we can simply use the Gauss law, integral E dot dA, which is the flux, is equal to the charge enclosed divided by epsilon naught. So one thing to note here is that the area vector will be outwards and the electric field will be inwards, which means E dot dA will be negative. The cos theta term will be cos 180, which is minus 1, which means the flux will be minus electric field, which is 150 Newton per coulomb, times area will be 4 pi r squared, where r is the radius of Earth, because Earth is a sphere. This is equal to charge enclosed divided by epsilon naught. This formula is important. We'll come back to it later. Hence, charge enclosed is simply minus 150 times 4 pi into r squared. We know that radius of Earth is 6.38 into 10 power 6 meters. And we know that epsilon naught the value of 1 by epsilon naught is 8.988 into 10 power 9 Newton meter square per coulomb square, giving us minus 6.793 into 10 power 5 coulombs. We'll call this, we'll say this is almost 6.8 into 10 power 5 coulombs, because we are given a number with only the numbers in the question only have two significant digits. Now, for the second part, we want to find out the charge density. Charge density is simply charge by area. So if we approximate that the charge on Earth's surface is distributed uniformly, then that will simply be total charge divided by 4 pi r squared. So that is equal to, if you remember the formula here, Q by 4 pi r square will be equal to epsilon naught times minus 150 Newton per coulomb. That is it. We know that the value of epsilon naught is 8.8 into 10 power minus 12 meters. 10 power minus 12 times 150. Remember that there is a minus sign here, giving us the total charge per area. But we want to find out the number of electrons per area, which means we want to take charge per area divided by a charge of individual electron. This will give us the number of electrons per individual area. So that is, as we saw, 8.85 into 10 power minus 12, that is epsilon, times the field is 150 newtons per coulomb, divided by the charge of electron is 1.6 into 10 power minus 19 coulombs. This turns out to be 8.3 into 10 power 9 electrons per meter squared.